we are now going to start a course on basic electronics. It is essentially a laboratory course. We are living in an age of information technology. Electronics is at the very foundation of the information and computer age in which we are living now presently. The giant strides that we have made in the areas of communication and computers are possible only because of the great successes that we have achieved in the field of electronics. It is sometimes unbelievable how many electronics gadgets that we carry these days in our person. For example, digital wristwatch, calculator, cell phone, digital diary or PDA, digital camera or video camera, etc. The different types of electronic equipment that has invaded our offices and homes these days are also mind-boggling. Many things we use at home and office are remote controlled. For example, the television or the air conditioners, the audio equipment, the telephone. We use a cordless, for example. It is almost close to magic how even a small child nowadays can switch channels or increase or decrease the volume of sound in a TV at home by just clicking on a few buttons at the comfort of a sofa away from the television, apparently without any physical wiring or connection. Again, we are astonished how we are able to talk to our near and dear, living several thousands of kilometers away from wherever we are, at home, office, or on the road in a car or in a classroom, by just clicking on a few numbers on our palm-sized cellular phones. Electronics has thus made deep impact in several vital areas such as healthcare, medical diagnosis and treatment, air and space travel, automobiles, etc. In short, the technological developments of several countries of the globe are directly related to the strengths in electronic design, manufacture, products and services related to electronics. It appears as though that we have to add inevitably an E to the 3 R's that we normally specify to declare a man or woman literate. The 3 R's are reading, writing and arithmetic or arithmetic. Needless to add that the E that I was referring to here means electronics. So apart from reading, writing and arithmetic, one should also have basic knowledge of the E or the electronics. Thus, electronics has become surely a basic science and it is no more an applied science. Just as we teach physics, chemistry, biology and mathematics in our schools, it is time we start teaching our children at school electronics as a separate subject by itself. This brings us to face to face to an important question: how to teach the basic concepts of such an important subject like electronics in the most efficient and effective manner. If one wants to gain a good grip and understanding of electronics, he or she should build circuits and test them independently. For this, one should acquire a practical knowledge of the characteristics of different devices and in constructing the various circuits. Let us try to learn such skills by a proven scheme of learning by doing. What is this? An old Chinese proverb says, I read, I forget. I see, I remember. I do, I understand. So if you need to understand and apply whatever knowledge you acquire, then it has to be by the method of doing rather than reading or seeing. There is only one way to learn to do anything. That is, just do it. That is the way we all have learned as a child even to talk, to walk, to ride a bicycle or whatever. Many arts and special skills like dancing, singing, swimming and martial arts are all learned by going to an expert or a teacher who makes us learn by doing rather than by listening to lectures or reading books. But why learning by doing is so important? It is very simple. The reason is, while doing, we are given an opportunity to fail. So failures are very important in the learning process. Nobody wants to fail, and if one fails, one starts wondering what went wrong. Thus, at the point of failure, there is a profound learning taking place. That is why people say failures are stepping stones to success. Before we go into the subject of electronics, it will be nice to look at some of the background, historical background of electronics. I will just mention to you some few landmarks in the history of electronics. The invention of vacuum tubes or the thermionic valve brought in the age of electronics long time back. Many new and exciting applications were found for these devices. Many great names like Edison, Marconi, Ambrose Fleming, De Forest, etc. are associated with the electronics. As a matter of fact, the transition from the diode to the triode, which has got 3 electrodes, was brought about by an ingenious suggestion by De Forest. He suggested that we can introduce a 3rd electrode in the vacuum tube diode to make it into a triode, and that really brought about a major change and development in the area of electronics. You can see some examples of vacuum tubes on the screen. These are different types of vacuum tubes used for in those days for amplification purposes and things like that. You can see they have a filament which is a thermionic filament. When you pass a current through that, there is thermionic electrons developed which are collected by an electrode which is called the plate, and you have another electrode, the 3rd electrode, which is a control grid, which is in between these 2 electrodes, and any voltage impinged on them will alter the flow of electrons between the 2 electrodes, main electrodes, the cathode and the anode. So that is responsible for the amplification and the such things. Now, after the war in 1948, the transistors were invented in the Bell laboratories in the USA by the 3 great people, Bardeen, Brattain and Shockley, and that brought in much greater miniaturization and applications in the area of radio electronics and things like that. On the screen you can see some of the examples of the transistors. Different types of transistors are shown in the photograph, and the major development in electronics came up with the introduction of integrated circuits. This invention is one of the major development in the area of electronics. Here transistor had become already commonplace in everything from radios to phones to computers, and therefore the manufacturers wanted something even better, something which is much smaller and much more powerful. And two people are associated with the invention of integrated circuits. They are Jack Kilby of Texas Instruments and Robert Noyce of Fairchild Semiconductors. And Jack Kilby was awarded the Nobel Prize in 2000 for his development of integrated circuit. Robert Noyce is no more at the time, and therefore Jack Kilby alone was given for the partial development of the integrated circuit ideas. Integrated circuits can be now found in almost every modern electrical device, such as computers, cars, television sets, CD players, cellular phones, etc. I will show you some photographs of that. The basic idea here is the semiconductors are used for preparing the transistors, but other devices like the resistors and capacitors have to be independently made by discrete methods. It was the idea of Jack Kilby and Noyce whether the same semiconductor can be used to also prepare diodes, resistors and capacitors. Resistors can easily be developed by doping the semiconductor suitably, and the capacitors can be developed by using a p-n junction diode in a reverse bias mode, and therefore diodes can be made, resistors can be made, capacitors can be made out of semiconductor. Therefore Jack Kilby and others thought, why not make the whole circuit, which involves different devices, to be made all completely using semiconductor. That is how the whole idea of integrated circuit came. You integrate the different components like transistors, diodes, resistors and capacitors, all made of basic semiconductor material on the same substrate. See, the bulk resistivity of the semiconductor and its diffusion dope layers could be exploited for fabricating resistors, p-n junction diode, etc. That's I already mentioned. So this is one of the first integrated circuit idea which was implemented by Jack Kilby in his lab. You can see it's very crude. It has got no resemblance to the modern, well-refined design of integrated circuits, which I'll show you in the next graph. You can see in this picture one of the integrated circuits, which is a memory chip, is shown here. And the other picture here shows the different integrated circuits. They have different packages. In all of these, you can see enormous number of transistors being prepared side by side, and few of resistors and very few capacitors and no inductances at all. So integrated circuits are characterized by very many number of transistors, few resistors, very few capacitors and almost no inductances. So that therefore the whole idea of integrated circuits completely modified the concept of circuit design. Instead of going for the distribution of various devices, in olden days circuits will have more of resistors, capacitors, etc. and less number of active devices like transistors, but with the introduction of integrated circuits the situation reversed. That is, we have more number of active devices like transistors, etc. and less number of resistors, capacitors and things like that. So this is generally the background of the brief history of the electronics. Now I'll move over to the table to show you some real transistors, vacuum tubes and integrated circuits. So here you can see the vacuum tube. This is a vacuum tube which is used for power electronics. You have number of pins and you will have a base into which these pins will go and the corresponding voltages will be applied. These are characterized by very high voltages of the order of 200, 300 volts, and you require a separate power supply for energizing the filament, and therefore you require large number of power supplies and they will dissipate enormous amount of energy, and therefore you will find they have to be cooled. If large big circuits are built with vacuum tube triode, the triodes and diodes, you require very efficient cooling systems. Whereas when you come to the transistors, these are the semiconductor transistors. You can see this is the smallest one, very small, 3-terminal device. Just as you have triode where you have plate, control grid and cathode, here you have again 3 electrodes, the emitter, the collector and the base. Here again you have a slightly bigger one, this is for higher currents or higher power. This one is much higher power, and this one is very large powers of several watts. I will just perhaps take it out and show it to you. You have 2 terminals only here, they correspond to the emitter and the base, and the casing becomes by itself one of the other electrode, which is the collector, which takes the brunt of the current in any given circuits. So these are transistors, different types, all made of semiconductor. Then we come to the integrated circuits. You have here a very tiny one which has got 8 pins on either side. These are called dual in line package. And you have much larger one, slightly larger one, which has got 14 or 16 pins on either side, 8 on either side or 7 on either side. And this one is a much larger integrated circuits, which has got about 40 pins, 20 on one side and 20 on the other. So these are integrated circuits which have got several transistors. For example, this will have easily about 20 transistors, this will be much larger, and this will have thousands of transistors inside. And the actual semiconductor will be somewhere very small, few millimeters square, and to make them easy to handle, they are put on a bigger package with a number of pins so that they can be connected into a real circuit outside. So these 3 are the modern integrated circuits. The latest integrated circuits in the computers that you see will have much larger number of pins of the order of 396, 400, things like that. And some of these transistors also on resistors, capacitors also, which we have to be used along with these for building different circuits, have come also in something called, very similar to integrated circuit, something called surface mountable devices. So along with these things, the miniaturization is complete. Therefore you have enormous number of applications coming out of them, including the things that you know of like the cell phone and things like that. They have enormous number of very tiny circuits built with several integrated circuits and several small devices like transistors, capacitors, resistors, etc., all found in one. They are all wired on one single printed circuit board. The circuit board itself will be printed with all the wiring pattern, and the whole thing will now is in the modern times it is all automated, and therefore large number of such things can be manufactured very quickly and very efficiently. And these devices, they also increase in the order of efficiency and performance. The vacuum tubes are not all that good because they have enormous amount of heat generated. These are good, but these are much better. They have these here, the transistors are very close to each other, and therefore the performance and reliability is enormously improved in these integrated circuits. Now let us see what we will discuss in this course on basic electronics. We have components and devices which go into the building up circuits. We have measuring instruments like different types, and we also have circuits to learn. For example, if you take the components and devices, you can classify them basically into 2. One is called passive components and devices. The examples of passive components are resistors, capacitors, diodes, inductors, etc. If you look at active components, there are transistors, operational amplifiers, etc. The passive components are basically, they cannot amplify, for example. They will only attenuate. If a signal or voltage or current is given to them, there will only be a reduction, if at all, after passing through these components. Therefore they are called passive. Whereas if you take the active components like transistors or op amp, there can be an enhancement of the voltage or current or whatever, and therefore they are called active components. Now if you look at the measuring instruments, one has to know something about the digital multimeters. Now most of them are digital multimeters. There are very few occasions when you come across analog multimeters. Power supplies, they are very essential for the powering the different circuits for working. Voltage sources and current sources, oscilloscopes for observing the different waveforms, and function generators, which are basically to generate different kinds of waveforms or signals. When you come to the circuits, you find there are different types of circuits like rectifiers, you have amplifiers, you have oscillators, you have filters, and so many different types of circuits. Now, what is the prerequisite of this course? The basic prerequisite we assume for this is that you have a general understanding of the principles of electricity and magnetism. That is all that is required to know from your side. Once you know that, we will be able to build on that foundation the whole subject of electronics, basic electronics, with a practical bent. We will attempt here to learn the basic principles of electronics by the scheme outlined, namely learning by doing. So what I am going to do is I will try to explain the principles of operation of the various devices, the measuring instruments, and the circuits that I outlined a little ago. I will also then demonstrate the working of the working principles by actually performing that part of the theory which we learned, by actually going over to a laboratory table and performing those experiments on a breadboard side by side. This, I believe, will enable you to get greater confidence in the principles and working of electronic devices and circuits, and therefore at a later time you will be able to build different circuits on your own and learn from them. Before we proceed further, it is important to understand how and where the different circuits will be built and tested. We will use what is known as a breadboard for constructing the different circuits and for testing. This is very useful here, as we do not have to solder the different components while we build the circuits. The normal scheme is to take these components and solder them together on what is known as a group board by soldering them. With soldering, I mean you will use a lead and then use a soldering iron, which is a hot iron, and then join the different components into various configurations of the circuits. If we do such soldering, then you can imagine the components will have to be cut into different sizes to match the circuit, as well as once you solder, the components may get spoiled. We may not be able to use the components again later on. Whereas in a breadboard, it is very convenient because you are not going to solder the components. You are going to just insert the components or the leads of the components into small tiny holes, which I would show you in a moment, and therefore you don't have to solder and the component need not be cut. So the resistors and the various components can be used repeatedly for different circuits. Let us now see how we can use the breadboard. What is the basic principle of the breadboard? I have shown on the screen a typical breadboard which will be used for building the different circuits. Many of you, I am sure, are familiar with this type of a breadboard perhaps. You can see the breadboard is a plastic board with number of holes on it, there is a pattern of holes. For example, you can see vertically there are 5 holes marked A, B, C, D, E on the screen on one side, and then F, G, H, I, J on the other side. So you have a whole row of such holes on either side with a small cavity in the center, and then you also see on either side, top and bottom, between the two lines, the red and the blue lines, there are a whole range of holes which are running parallel to the length of the rectangle. Now these lines which are running at the extreme ends between the two blue and red lines are called power lines or rail lines. They are generally used for connecting the power supply lines for the various circuits. The other holes which are marked A, B, C, D, E, etc. are basically 5 holes in a node, and they all correspond to one single node. They are, most of the time when you build circuit, you would find you require many points to be connected together. Now here we have 5 holes. That means 5 different components or wires can be connected together to one single point. That is what we mean by the 5 holes node here. How is it done? For knowing this, let us look at the figure that we have on the screen, where you can see, for example, below that holes in the breadboard that I showed, you have a set of clips, metal clips in the form shown in figure A. This is basically a metal clip which has got very narrow hole at the point where I show, and when you insert a component, for example here in figure B, a resistor is shown. When I insert the resistor inside that clip, the clip expands a little bit and grips the lead of the resistor at this point. So that is how the connection to the resistance is made at these 2 points. And this clip is actually very long, as it is shown in figure C, which will actually align below the 5 holes that you saw on the breadboard. So by connecting different components through different holes corresponding to the one set of 5 holes, you would find you will be all interconnecting them, because all of them have got individual clips below them which are all connected by a single metal frame.